గుడ్ మార్నింగ్ టు ఆల్. ఈ ప్రశ్నకు బదిలేది. In this program, I want to give two questions from states of matter, gaseous state, liquid state. The first question is what are the states of matter? What are the states of matter? What are the states of matter? Second question is what are the intermolecular forces present in the matter? These two questions are very important for short questions or 4-mark questions. First of all, I want to tell about the what are the states of matter. What are the states of matter? Generally, matter is in 4 states, 3 states especially. This is a special state, plasma state, solid state, liquid state, gaseous state and plasma state. In solid state, what happens? The molecules or atoms are systematically arranged in crystal lattice. Crystal lattice. So, the distance between the molecules, atoms or ions is very less in solid state. They have systematic shape, systematic structure, systematic shape or structure. This is the diamond is a good example for this. Another one is liquid state. In liquid state, the distance between the molecules or ions or atoms is somewhat far from the distance is more than the in solid state. That is the reason it has no shape, fixed shape. It is a good example is any liquid, water or juice or thing. So, it may be compressible. It may be compressible. The compressibility is somewhat less. So, if you put pressure, the volume will be decreased, the compressibility. When you increase the temperature, so what happens? The liquid state becomes gaseous state. In gaseous state, the distance between the molecules or atoms or ions are somewhat far from the somewhat more than the liquid and solid states. Good example is a cloud or normal gases, nitrogen, in which is at room temperature, hydrogen, nitrogen, oxygen are the normal gases. They have compressibility, they exert pressure, they occupies more, the weight is less, they occupies more area. And the shape also they have no shape, they occupies they have shape of whichever container they are existed or they are present. So, next one is plasma state. Plasma state, when these are undergo these gaseous molecules are undergo ionization, you will get a positive cloud and a negative cloud for ions. So, that is the reason generally the clouds between positive cloud and negative cloud you will get thunderbolts. So, this is the plasma state of the at particular state you will get a plasma state before raining of the clouds. So, these are the various examples. How can we convert one state to the other? The solids are melting, the distance between molecule increases. If you give thermal energy, the distance between the molecules in the solid state increases. So, you get a liquid state. Liquid state, if you give further energy, further thermal energy in the form of temperature, it undergo vaporization to get the gaseous molecule, where the distance between the molecules is more. If you subject this gas to the ionization, you will get plasma, the positive clouds and negative ions. So, gaseous positive and negative ions are this generally plasma state, you can say. So, these are the various states of the matter. Now, what are the various types of intermolecular forces in matter? In matter, what happens between the attraction or repulsions forces are there in the between the molecules or atoms in the substance are called intermolecular forces. The forces of attraction or repulsion between molecules or atoms in the substance are called intermolecular forces. These are also called as van der Waals forces. What are the, give us some examples of the intermolecular forces generally, that is the 2 marks question, a short question, very short question. So, what are those forces? London dispersion forces, these can be called as London forces or dispersion forces, or LDF, London dispersion forces. Dipole attractions, dipole attraction forces, dipole induced dipole forces, hydrogen bonding, repulsion forces. The first 3 are called van der Waals forces. Van der Waals is a scientist. He proposed the intermolecular forces. These 3 are very weak forces. They are generally molecules just this type of forces. So, here elaboratively we can see this in next page. In London dispersion forces. In London dispersion forces it happened in symmetrical molecules. In symmetrical molecules what happens, they will be molecules are mostly atoms or molecules are spherical, atoms spherical. The positive charge, the electron cloud is symmetrically spherical. When they are coming closer, the nucleus of the one at a particular stage, very short while, the positive charged nucleus attracts the electron cloud of the other molecule. So, it will be distorted, it will be dispersed. Similarly, these positive charge may attract this electron cloud of the other molecule. So, that they will be dispersed, they get positive and negative ends, positive and negative ends. So, the negative end of the one molecule, the positive end of the other molecule, they will be attracted short while, very weakly attracted. So, this is called London forces or dispersive forces. It is the very weakest forces of weakest intermolecular force. Its bond energy is 1 kilojoules per mole, 1 kilojoules per mole. Then a good example is fluorine molecule F2. This is F2, this is F2. It is a neutral molecule, it is neutral molecule. The influence of this molecule is on this, it will be dispersed. Similarly, this molecule disperses this molecule. So, there will be some positive and negative charges that causes some attraction. That attraction is known as London dispersive forces, LDF. What about the dipole induced dipole forces? Dipole induced dipole. Dipole is nothing but a permanent polar molecule, hydrogen chloride. Hydrogen chloride is it is not pure covalent bond, because the mutually shared electron pair is not at the center, it is attracted towards the highly electronegative chlorine atom. So, that towards itself. So, it gets partial negative charge, hydrogen gets partial positive charge. So, it is called polar molecule, it is a permanent polar molecule. HCl is always having partial poles, delta hydrogen, delta plus and hydrogen and delta minus on chlorine. Such a molecule, when it is coming to the a neutral molecule, non-polar molecule like chlorine, then what this attracts the electron clouds. So, that it will be polarized. So, plus and minus polarized. So, there will be some attraction. This minus the polar molecule delta minus, the induced delta plus of the non-polar molecule, there is some attraction. Such attraction is known as a dipole induced dipole attraction. The internal energy is directly proportional, inversely proportional to r to the power of 6, r to the power of distance to the power of 6, distance between the molecules. This is bond dissociation energy is somewhat stronger, 2 to 10 kilojoules per mole, 2 to 10 kilojoules. This weakest intermolecular force, this is next it comes. What about this dipole? Next one is dipole attraction forces. Dipole is a permanent dipole hydrogen chloride, another permanent dipole hydrogen chloride. Delta plus hydrogen, Cl has delta minus, partial negative charge. So, other molecule positive charge hydrogen is attracted by the chlorine. So, there is an attraction. Similarly, this Cl is attracted by hydrogen plus of the other molecule. So, see this type of attractions are known as dipole. This is a dipole, permanent dipole, it is a permanent dipole molecule. So, the attraction between these permanent dipole molecules is called dipole-dipole attraction. It is a stronger one than dipole induced dipole, 5 to 20 kilojoules per mole, 5 to 20 kilojoules per mole. This is 2 to 10, this is 1. So, when it is a solid state, the internal energy is directly inversely proportional to r cube, distance between the molecules. If it is a angular molecule such as water molecule, rotation is possible, then internal energy directly under the attraction forces is directly proportional to inversely proportional to r to the power 6 or directly proportional 1 by r to the power of 6. So, this is another those three are called van der Waals force. This is hydrogen bond. Hydrogen bond is you can study in a chemical bonding chapter in detailed manner. Here hydrogen bond is a weak electrostatic attraction force formed between hydrogen atom bonded to the highly electronegative oxygen or nitrogen or fluorine. The hydrogen which is bonded to the highly electronegative oxygen or nitrogen or fluorine, that is attracted by the either oxygen or nitrogen or fluorine such with a partial bond, partial electrostatic attraction, weak electrostatic attraction. Such weak electrostatic attraction is called hydrogen bond. The bond energy is 10 to 100 kilojoules per mole. So, it is the strongest bond intermolecular attraction when compared to the all other intermolecular attractions. In your syllabus, hydrogen bond is there. There is a ion attraction is also there, which is strongest one, but this is the strongest one in your syllabus, which is intermolecular forces 10 to 100 kilojoules per mole. So, hydrogen bond. So, molecules in which the hydrogen bond is there, such molecules are known as associated molecule, associated liquids. Water is associated liquid due to presence of hydrogen bonds in between the molecules. Similarly, ammonia is also associated liquid, because between ammonia molecules the hydrogen bond is there. Similarly, HF is also associated molecule. Association, molecular association is due to presence of hydrogen bonds between the molecules, is called associated liquid. Hydrogen, what is the bond energy of the hydrogen bond? 10 to 100 kilojoules per mole. Which is strongest intermolecular attraction? Hydrogen bond. Anyway, the next one let us see in detailed way the comparison of bond energies. Weakest one is London dispersion forces. This is the round one. After polarization, they will be like this. The attraction, this attraction is 1 kilojoules per fluorine or Cl to Cl2 molecule. This is one molecule, this is a non-neutral molecule, symmetrical molecule. The attraction is happened due to short while polarization. Such nature is called London forces or dispersion forces or LDF, London dispersion forces. So, the another one is dipole induced dipole. Dipole, this is dipole HCl. Another one is induced dipole. This is neutral molecule. Neutral is round, you see round, that will be polarized after due to attraction of this molecule, due to influence of this molecule. So, the energy is this is 2 to 10 kilojoules per mole. Ion induced dipole, which is not in your syllabus, but it is a stronger bond. Ion Fe2 plus, it polarizes the neutral molecule. Ion Fe2 plus, positive ion, polarizes the O2 molecule. O2 is a neutral molecule, symmetrical molecule. So, such attraction is the energy of the such attraction is known as 3 to 15 kilojoules per mole. Next, dipole attraction, HCl and HCl or ICl and ICl or HBr and HBr. So, these both are polar molecules, permanent polar molecules. The attraction between the polar molecule is positive charge and this negative charge. So, you will get it is somewhat stronger 5 to 25 kilojoules per mole. Hydrogen bond is a H2O and H2O. So, HF and HF, similar way ammonia and ammonia. So, these are associated molecules 10 to 40 kilojoules per mole. In our syllabus this is not there, but it is also very strongest rather than hydrogen bond also. Ion, sodium plus ion, and dipole, it is a dipole. Water molecule HCl, H2O is a dipole. The attraction between the ion and dipole, such attractions also somewhat possible, some rarely. That attraction is bond energy is 40 to 600 kilojoules per mole. So, this is the thing. So, thank you. Please do subscribe to get more videos and to more clarifications of your doubts. Thank you very much.